All right, so for the last part of the week, as I said, we're going to look at something a little bit different, and it involves writing complex numbers in trig form. If you hear me say polar form, it means the same thing. I'm teaching it from a different book. Sometimes they call it something different. But I'll try to use the word your book uses. So quick review of what a complex number is. Remember, complex numbers are written like that. A plus bi. That's called standard form. That's not trig form. That's what we're going to learn. So here's an example of a complex number in standard form. You would say that this number has a real part of 3 and an imaginary part of 2. So that's standard form. Now, another way to represent a complex number is graphically. And if you want to write a complex number in trig form, you have to know the quadrant it's in. So that's kind of the point of this. Graphing it will show you the quadrant. Okay. So overall, it's pretty easy to graph a number, to graph this number. It's almost just like graphing the coordinate 3, 2. Basically what you'd be doing. So what we're going to be doing is graphing in what's called the complex plane. The complex plane is a coordinate plane, but it doesn't have an x and a y axis in it. That's not what you call them. The complex plane has 2 axes. We call one of the axes the real, and we call the other one the imaginary. X is the real, y is the imaginary. As far as the directions, it's just like an xy axis. Positive is to the right and up. Negative is to the left and down. So to graph a complex number, like let's say you wanted to graph 3 plus 2i. The real part is 3. The imaginary part is 2. So what that would mean is go to 3 units on the real, and then go to 2 units on the imaginary. So just like this. 3 units in the positive, 2 units up. That would be the point 3 plus 2i. That's why I said it's just like graphing the point 3, 2. Same rules. Different names for the axes, but it's kind of the same. Right, let's try a couple others. Let's try -4 minus 2i. So starting at the origin, can somebody tell me how I would get to the location that's -4 minus 2i? Which way would I go? Yep.
You go left 4 down 2.
Right, go to -4 on the real axis, and then go to -2 on the imaginary. So that's left 4, down 2. Perfect. How about -2 plus 3i? Can someone else tell me how to get to that one? Chris?
Go left 2, up 3.
Left 2, up 3. Go to -2 on the real axis, and then go to +3 on the imaginary. So -2, up 3. Okay. How about 5i? How would I graph that one? Yep.
Up 5.
Yeah, there's no real part this time, so you could just think of it as 0 plus 5i. Don't go left and right. Up 5. Okay, so there's that one. How about 6? Francesca?
To the right 6.
To the right 6. Think of it as it confuses you. Think of it like that. 6 plus 0 imaginary. So just write 6. Now, the important thing to understand there is basically figuring out the quadrant that a point is in, because that's going to be part of writing something in trig form. So questions on graphing the points? Okay. So next thing I want to think about, and this is also going to be part of writing a number in trig form, is absolute value. How do you, well, there's lots of ways to do this, but how do you define absolute value? Can somebody tell me what that means? You're trying to find the absolute value of a number. A lot of people think of it in a very geometric way. It's almost like a distance kind of way. Yeah?
It's like the number, but positive no matter what.
Okay, which means, what does that mean? If it's the number and it's always positive, it's almost like the absolute value measures something. Yep.
The distance from 0.
Right, it measures the distance from 0. Now, when you say 0, that's a very one-dimensional concept. That means it's the distance from a point. What do we call 0 in 2 dimensions? Like if you have an xy axis, you don't really call it 0. Yep.
The origin.
The origin. So if you want to find the absolute value of a complex number, like let's say 3 plus 2i, what that means to do is this. Find the distance that point is from the origin. That's the absolute value. And anyone have a guess how you would figure out how long that line segment is? Yeah.
Wouldn't it be 3? Because it'd be 3 over on the right. And the dot's up 3.
Well, the dot's up 2.
Oh, yeah.
So it's right 3 and up 2. But I don't think that means it'll be 3 long. Yeah?
It'd be 2/3.
2/3? So 2/3 of a unit would be about like that.
Oh.
Because this is 1 unit. So that's about 2/3. So it definitely is longer than 2/3.
I was thinking like the slope of the.
Oh, okay, yeah. Yeah, that would be the slope. Rise over run. But anyone have another guess? Yeah?
Would be the distance formula?
Okay, you could use the distance formula because you know the location of the start point and the end point. And what I'm thinking of is basically the distance formula, but make a triangle out of that. Find the length of the hypotenuse. The bottom side is 3, the height is 2, and the hypotenuse is the square root of 13. So when you want to find the absolute value of a complex number, that's the distance it is from the origin, which usually ends up being a hypotenuse, which means you're going to use Pythagorean theorem. All right, so let's say you had a point instead of something specific, just say you had a real part and an imaginary part, and you graph it. A is the base, B is the height, and to find the length of that line segment in red, a squared plus b squared, and take the square root. And use Pythagorean theorem. So that's the formula to find the absolute value of a complex number. It's just measuring the distance from what we call 0, or the origin. So let's try an example where we find the distance. Now, another thing people kind of call this, instead of thinking of it as an absolute value, eventually we're going to think of it like this. Which in that case, now it's a radius. It's the radius of that circle. when we start writing numbers in trig form, that's how we're going to think of that line segment in red. We're going to call it the radius. But it's really the absolute value or the hypotenuse. Right, let's try this one. So the absolute value of 3 plus 4i. If you forget how to do it, you can always just make a sketch and then figure it out from there. So I want to find the length of that line segment. Make it into a triangle. How would you set up your Pythagorean theorem to find the absolute value of 3 plus 4i? Eli?
It would be the square root of 3 squared plus 4 squared.
Yeah. 3 squared plus 4 squared. And what's the square root of 3 squared plus 4 squared? Yeah. 5. So another thing about absolute value, it's always positive because it's measuring the distance to the origin. Well, I guess I shouldn't say it's always positive. It'll never be negative. It could be 0. If your point was 0 plus 0i, then the distance from that point to the origin is 0. Okay, question on finding absolute value. All right. So, now let's take a look at how we write a complex number in trig form. Instead of using a and b to represent the real and the imaginary part, I'm going to start using x and y. I think it'll be easier to remember. If I use x, you'll remember, oh yeah, that's horizontal, and y is vertical. So let's say you had a complex number that was x plus iy. You might be like, wait, don't you normally put the I after? You can. Yes, I've been writing like A plus BI. This is like writing IB. I'm just doing it that way because you're going to see in your book the formula, and I'm just trying to make it match. Alright, so this has a real part of x and an imaginary part of y. When you write a complex number in trig form, you are not allowed to have an x or a y. You can't have them. X and y is standard form. We have to replace the x and the y. What are we going to replace them with? Let's see. So what I've drawn here is your point again in quadrant 1. I've gone to the right x units. I've gone up y units. I drew in a dotted line, and I'm calling that dotted line, that's the hypotenuse, r. Okay, the reason we're going to call it r is because I want you to think of it like that. It's the point on the edge of the circle. Now, when you write a number in trig form, okay, what they'll give you is two things. Not an x and a y, but they'll give you an r and a theta. R is how far out you've moved, and theta is an angle you've rotated. That's how you write a complex number in trig form. A distance from the origin, and then an angle of rotation. So let's start by replacing x in my formula. Here's x. Here's a distance from the origin. Here's an angle that represents a certain amount of rotation counterclockwise. What trig function would relate x and r? Would it be sine, cosine, or tangent? Yeah?
Cosine.
Yeah, very good. It would be cosine. So the cosine of this angle would equal Cosine is adjacent over hypotenuse. Is there any question why that equation is true? The cosine is x divided by r. Because what I would like now is a formula for x. And once I get that, I can substitute it in. And then I won't have an x anymore. And that's what I want. I want to get rid of the x. So what would x equal based on the formula cosine equals x over r? Sarah?
R cosine.
Yep. So in a minute, we'll fill that in for x. And now we need something we can fill in for y. Here's y. Here's r. Here's theta. What trig function could we use this time that would relate y and r? It's not cosine. Yeah? Sine. The sine of theta would equal, can someone tell me what would go on the other side?
Y over R.
Sine is opposite over hypotenuse. Y over r. And again, the whole point is to find a formula that I can use substitution for with the y. So let's get y by itself. So Matt, what's y going to equal? That'll be part of it. It's going to have a little bit more in the box than just that. Okay, different question. How do you get y by itself there?
Divide or add.
Well, we already have a divide here, so you want to cancel out division. How do you undo divide? Because we want to get rid of y divided by r. I just don't want this divided by r here. So what could I do on both sides that would get rid of dividing by r? What did we do on the one above it? I probably should have written it down, but I think somebody told me and I just wrote the formula. Do you remember what we did on the one above it? Want to help them out? Yep. We multiplied both sides by r. Right? So we did times r, these canceled, and that's how we got that. Times r, those cancel, and there's your formula for y. In trig form, you want to have an r and you want to have a theta. You don't want to have an x and a y. So now, we've got something we can plug in that will get rid of the x and the y. All right. So plug in that for x, plug in that for y, and you're going to have r cosine theta plus I r sine theta. Right, so that's basically trig form. We can simplify that a little bit because if you look at each term, what factor does each term have in common that we could pull out? Yep.
R.
They each have an r. So what we can do is pull an r out of this and then just write it in front of everything. You'd be left with cosine theta here, and you'd be left with I sine theta in the second spot. And that's the trig form of a complex number. So instead of writing x plus iy, we're going to write this. R cosine theta plus I sine theta. So even in this form, there's still two numbers you have to write. You have to write a number for the radius, and you have to write a number for the angle. So remember, r is the radius, theta is an angle. And we've already talked about how to find r, right? That's the distance from the origin. What did we call this earlier? The distance from the origin is just the what in my complex number? Yeah.
Absolute value.
Absolute value. All right. So when you find the absolute value of your number, you're doing part of what you need to do to write it in trig form. Now, the other thing you need is theta. Let's just make up a point. 3 plus 2i. And I want to find the angle for that point. Oh, there's 3 plus 2i. There's your radius. That's your angle. Now, when you graph this point, 3 plus 2i, you're going to know the length of the bottom side and you're going to know the height. What trig function can you use to get your angle? Think about this like you're solving a right triangle, and I just want you to tell me how big this angle is. That's basically what you have to find. Well, what two sides are involved from the perspective of theta? I mean, I know the length of the sides, but I'm looking for the names of their position. Yep.
Opposite and adjacent.
Yeah, opposite and adjacent. So you're trying to calculate an angle that involves an opposite and an adjacent. What trig function is that? Yeah. Tan. Yeah. So when you want to find the angle for a complex number, you can start by doing this, which is really the tangent, whoops, that should be theta. The tangent of your angle equals 2/3. 2 is the imaginary, 3 is the real. But then you have to get theta by itself. So if we wanted to finish that, how do you get rid of tangent? Yeah.
Take the inverse of it.
Take the inverse. Okay, so you do the inverse tangent of what's on each side. I'm not going to finish that or write it out because I have it nicely written on the next page. Right, but we'll do a problem like that in a minute. All right, so to find r, I don't think I need to really go into much explanation. We've already done that. Use the Pythagorean theorem. Now, to find theta, this is where it depends on the quadrant you're in. And you might be like, wait, what? I thought you could just use inverse tangent and we're done. Well, you basically use inverse tangent. And if you're in quadrants 1 and 4, that's exactly what you do. It's the inverse tangent of your y value, the vertical, divided by the x value, your horizontal. The inverse tangent of your y value, the vertical, divided by the x value, the horizontal. But the problem with inverse tangent is it's very limited in where it gives you an answer. Inverse tangent will only give you an answer from -90 to 90. What two quadrants does that mean inverse tangent always will give you an answer in?
What was the question again?
What two quadrants is inverse tangent always going to give you an answer in?
1 and 4.
1 and 4. Well, that's not good. Because if I gave you the point -2 plus 3i and you graph it, that's not going to be in quadrants 1 or 4. Meaning inverse tangent by itself can't give you the angle for that point. So what we have to do to get answers in quadrants 2 and 3, very simple. All you have to do is add 180 to your answer. Or pi if you're doing it in radians. So if you graph your point and it's in quadrants 2 or 3, you're still going to use inverse tangent. But almost think of it like a reference angle. It's not your final answer. You have to add 180 to it. Now, these two situations don't cover everywhere you could be. This covers if you're in quadrants 1, 2, 3, and 4. Where else can you be besides quadrants 1, 2, 3, and 4? Sarah?
You could be on the axis.
You could be on an axis. Now, tell me what you know about the coordinate for that point. It's on the axis. I just picked a point on an axis somewhere. I don't know exactly where it is. I'm just telling you it's on the y-axis. Yep.
Well, I was gonna say it'd be 90 degrees, but it's not a circle, so never mind.
Yeah, I want to know the location of it, like the x value and the y value, as specific as you can be. Yeah?
It would be 0y.
Yeah, it would just be 0, comma, however high up you are. The point here is, look at this number. He just told me the x value is 0. If you try to plug in an x value of 0, can you plug in a 0 into the bottom of a fraction? No. That's why if you're on an axis, it's a special case. What do? You just have to memorize the answer. If you're on the right, it's 0. If you go up, it's 90. Left is 180. And down is 270. Those are 4 special cases. Now, that covers everywhere you could be. In a quadrant, you've got a formula to figure it out. It takes a little longer to use a formula. Or, the special case is very fast because you're on an axis, so you can do it real quick. If you don't remember what those 4 angles are in radians, they're 0, pi over 2, pi, 3 pi over 2. 0, 90, 180, and 270. All right, so I've shown you how to find the angle. I've shown you how to find r. I've given you everything you need now to write a complex number in trig form. Then, once we know how to write a complex number in trig form, certain arithmetic things become very easy. Much easier than they used to be. Right, so let's try writing this number in trig form, and then I'll show you how we can do something a lot easier than we used to, as long as you understand what we did today. Right, so -2 plus 2i. First, can someone just remind me, what are the 2 things that you need to write a complex number in trig form? It's not an x and a y. We want to get rid of the x and the y. Yep.
The radius and theta.
Yep, we need the radius and we need the theta. They're totally separate. You can do either one of them first. I like to do r first. All right. If you're that kind of person who likes a visual, we can set it up. You don't need it, but it might help you, especially to figure out what quadrant it's in. Hopefully you can figure it out just by knowing you're going left and then up. So there's your point. There's your radius. there's the triangle you're going to solve to find the radius. Right, so Abigail, could you set up Pythagorean theorem for me to find my radius? You don't have to do it all out. Or were you trying to do the whole thing out? Or I just want to know like what we would set up and then we're going to do it out together. So you're trying to find this. What's the formula for Pythagorean theorem? Okay, and now if you fill in these numbers into what you just said, how would you write it? All right, I'm just going to call it r squared because that's our hypotenuse. And what would be the rest of it?
2 squared
Plus 2 squared. So when we simplify that, we're going to get 4 plus 4, which is 8. So I need a little more space down here. Which means if r squared equals 8, what's r? Yeah.
Square root of 8.
Yeah, we can leave it as the square root of 8. If you want to reduce it, you could do that. You can reduce square root of 8 as square root of 4 times square root of 2. If they asked for a decimal, you could even just type it in and get the decimal. All right, but there's my radius, so hang on to that. We'll come back to it. Now, the next thing I need is my angle. The angle, if you're not on an axis, the angle depends on the quadrant. We are not on an axis. Zach, what quadrant am I in?
The second one.
Yep, we're in the second quadrant. If you're in the second quadrant, do you have to add 180 to find your angle? What do you think? Yes. If you are in quadrant 2, it says the formula is 180 plus the inverse tangent of y over x. So that's the formula you have to use because you're in quadrant 2. So let's do it. So 180 plus inverse tangent of y over x. Well, there's your y and your x. In this case, if you switched them, you'd be okay, but you really should know which one is which. Y is the vertical, x is the horizontal, or the real. 2 divided by negative 2. And Chris, if I divide 2 by negative 2, what do I get?
1.
Negative 1. If you type that in on your calculator, you'll get negative 45. That's the inverse tangent of negative 1. What's 180 minus 45? Yep.
135.
135. So now we've done like 95% of the work. We have everything we need. Now write your final answer. To write your final answer, take the two numbers that we just found, fill in the r right there, fill in the theta right there, and stop. Don't do anything else after you just change this and that to what we just found. So r cosine theta plus I sine theta. Okay, final answer. R cosine theta plus I sine theta. That's the final answer. Now, if you're looking at it and you're like, well, wait, there's some stuff I could do out there. I could actually type cosine 135 in on my calculator, and I could distribute 2 root 2. Right, you could. And if you took the cosine of 135 on your calculator and distributed 2 root 2 to it, you'd get -2. And then, if you took the sine of 135 on your calculator and multiplied that by 2 root 2, you would get +2. If you did this out, you'd be changing it back to what you started with. So you can do it out if you want to check your answer, but if they want you to write it in trig form, that's where you want to stop. Okay. All right. Any question on that? So once we understand how to write something in trig form, it makes something that I taught you about complex numbers kind of irrelevant. It makes it go away. We don't need it anymore. The reason we needed it is because we didn't know how to do this yet. Now we know how to do this. And what trig form makes very, very simple is multiplying and dividing complex numbers. Adding and subtracting is already pretty simple. I can't do anything to make that easier. Right? Adding and subtracting, you combine your reals and you combine your imaginaries. But let's just do a quick division problem the old way before we learned how to do what we just did, just to remember kind of how annoying division with complex numbers used to be and how this is all going to go away in a second. So if you wanted to divide these two things, the first thing you had to do is multiply the top and the bottom by something special. Does anybody remember the name of the special thing you have to multiply by here? Begins with a C. Yep.
I was going to say reciprocal, but that's...
No, not reciprocal. Remember? Yeah. No, not common denominator. That's something we've done a lot of stuff with common denominators, but not with this one. Anyone else have a guess? Next letter is an O. C-O. Yep.
I don't know what it's called, but is it like we put the denominator in both sides?
You're going to do something with the denominator, but you have to change it. You have to make one change to this denominator. So I hope you're seeing how hard, or maybe not hard, but all the things you have to remember to do this. We don't remember the first thing. So that's why this is annoying to have to do it this way. Yep?
Cosine?
No, not cosine. There's no trig involved here. Just algebra.
What's the third letter?
M?
N, you're right.
What do you want to say?
I don't know what to say. Like convent or something?
Convent?
Maybe not. I don't
No,
know.
convent, that's where
She grew up with it.
not good. But the conjugate.
Oh, yeah.
Remember conjugate?
Yeah.
So the conjugate is when you multiply the top and the bottom by 5 minus I. Now we haven't even done it. We just remembered what to do. Now we have to do it. So now we have to distribute that out. And then in the bottom, it's not even as simple as distributive, it's FOIL. That's double distributive. So we got to do 5 times 5. I guess the nice thing here is 5 times negative I, 5 times positive I. That cancels. So you don't have to write that part down. But now, something else you have to remember. Positive I times negative I. Well, positive times negative is negative, but what's I times I? Yep.
I squared.
That's I squared. But I squared is something special. Anybody remember what number that is? Yep.
Is it a -1?
Negative 1. So now we got to change that. So it's really this. And instead of saying minus I squared, let's say minus what was just said, negative 1. So it really becomes 26. And we're still not done, and all this last part's pretty easy. We just have to separate it into 2 parts. 526 minus 326. That's your final answer as a real and an imaginary part. So a lot of things we had to remember how to do to divide complex numbers. Now, that's standard form. If we do this in trig form, all of this goes away. We don't have to remember any of this. And that's what I'm going to show you. And it's very easy. Yeah?
How did you go from 15 to 5?
15 to...
Like 15 minus 3 and 5 minus 3.
no, I didn't.
Oh. I was like, I'm so confused.
Looks like 15 to me.
Yeah, it does. Yeah, I
Yep.
saw that. I think I'm just like imagining stuff.
You know what it is. It's the glare. You couldn't see the one.
Okay, yeah.
Yeah, it's the
Yeah,
glare.
I'm sure that's what that was.
It must have been. Thank you.
This time I
All right. So, again, a lot of stuff you got to remember. Well, let's look at how we could take two numbers and multiply them together in trig form. So if they're in trig form, they're going to be written like this. You'll be given a radius, and you'll be given an angle. In this case, it looks like the angles are in radians. That's fine. I don't know the specific radius and angle you're going to have in every problem, so I'm just representing it generically. Your first complex number will have a radius. Your second complex number will have a radius. The first one will have an angle, and the second one will have an angle. Not sure why, but generally when you don't know a complex number, they just call it z. So complex number 1, complex number 2. Now, to multiply these two complex numbers together, you only have to do two things. It's not going to involve conjugate, it's not going to involve distributive property, foiling, I-squareds, it's not going to involve any of that. Only two things you have to do are take your first radius, your second radius, and multiply them together. That's half the problem. The second thing you have to do is take your first angle, take your second angle, and add them together. And you're done. So multiplying R1 and R2 together and adding theta 1 and theta 2 together takes the place of all that stuff that we had to do before. Right? It's much easier. So that's the formula for multiplying. And the formula for dividing is very similar. If you wanted to divide z1 by z2, you're going to take your two radii, and you're not going to multiply. Does anyone have a guess what you would do with R1 and R2 this time? Yep.
Divide them.
You're going to divide them. And you're going to take your two angles, theta 1 and theta 2, but you're not going to add them this time. What do you think you're going to do if you want to divide them? Yep.
Subtract.
Whoopsies.
Now I know why the deans had to speak to you. I'm just kidding. Go ahead, Jake.
Subtract them.
Yeah, you're going to subtract them. Now, of course, you would never be given a situation where one of the radii would be 0, because then you could be dividing by 0, and then that's a problem. But that's it. These two formulas take the place of all the stuff you just have to remember. You just have to remember which one you're doing. Multiplying, you multiply and add. Dividing, you divide and subtract. That's the biggest thing people mix up. But you can make a reference sheet, so I would put those two formulas on the reference sheet. All right, and I'm just going to make up a problem, and we'll do multiplication, and we'll do division. I'm going to make one up with nice numbers. You might not always have nice numbers. Use a calculator if you need to. All right, let's do... All right, so let's find Z1 times Z2, and Z1 divided by Z2. All right, here's Z1. let's do 12 cosine 200 plus I sine 200. And Z2, let's do 4 cosine 50 plus I sine 50. Now, what could be a little annoying about this is if you had to figure out these two things first. I taught you how to do it, but that's going to take longer. So for this one, I'm just giving you the two numbers. Let's pretend you already figured these out somehow. Now let's multiply them together. If I multiply Z1 times Z2, what's my new radius going to be? Chris?
48.
48. You take your two radii, multiply them together. And the last step, we're going to take the two angles, and what do we do with those? Yep,
Add them.
add them up. So 200 plus 50 gives me 250. And that's it. We did that a lot faster than we did that first division problem with conjugates and all that stuff. That's your final answer. All right, and let's divide. What's going to be my radius if I divide Z1 by Z2? Eli? 3. Take your two radii and divide them. And what's going to be my angle? Yep.
150.
150. Subtract them. If you didn't know how to do trig forming, to do Z1 over Z2, we would have to find the conjugate, FOIL it out, change the I squared to -1. We'd have to go through all that. Now we don't have to do any of it. And those are your two answers. Okay, so I said at the beginning, there'd be 4 things that we're going to learn how to do in trig form. We're going to multiply, we're going to divide. Okay, we did those two. Tomorrow, we're going to learn how to raise something to a power, and then how to undo that, which is how do you take a root. So we'll do those two to finish up tomorrow. Remember, tonight will be the last homework from the book. Tomorrow, the homework will be 5 questions from the test. And then on Friday, we'll finish the other 5 questions in class. You could do the take-home part pretty much right now. That's going to be on law of sines and law of cosines. This will be part of the in-class test. So those are the questions for tonight on 450. Reminder again, I will not be after school on Thursday because of open house. So if you need to see me, I'm free any period tomorrow up until your period. Or I'm free Friday as well if you need to come see me before your test.